So I started out by flipping a coin and coming up heads and heads and heads often enough that you finally said, nah, I don't believe you. And you're right. And so our innate sense of, the fact that there's a small chance that you could flip a coin 10 times in a row and get heads each time was kind of violated. And so what you're doing is kind of like a small hypothesis test. Now your hypothesis test always involve population parameters. So let's remind ourselves the notation for parameters. What are our parameters that we've worked with in this class so far? I'll give you a hint. 2 of them are Greek letters. Mu and sigma. And there's one more population parameter that we've dealt with so far. What is it? P. Yeah. Let's be careful. What would P hat be? Estimate. Yeah, that's the estimate. Well done. Thanks, Nicholas. P hat would be the estimate. That's your sample statistic. So this goes along with your mean. Here's your standard deviation. And here's your population proportion. So in Chapter 8, we're going to test claims about all 3 of these different things. Now in our first example, my flipping the coin example, we'd be testing a population or a claim about a population proportion, the proportion of times that you could end up with a head. Other circumstances might mean a mean or standard deviation. These are all going to be different sections in this chapter. This will be 8.2, this will be this will be 8.2, this will be 8.3, this will be 8.4. But one thing's going to be true about all your claims about a population parameter and our hypothesis test of those claims. They're going to start out with, first of all, a claim about a population parameter that's going to contain the possibility of equality. So one of these 3 things has to be part of your null hypothesis. Now our null hypothesis is going to be denoted with H naught, H sub 0. And H sub A is the alternative hypothesis. Just kind of a quick FYI, I think the book uses H1 for the alternative hypothesis. I like HA. It just seems to go with what we're thinking a little bit more. So we're going to spend a little time practicing the setup on some of these things. Contains a possibility of equality, set up our null and alternative hypothesis. Now our null and alternative hypothesis work a lot like this coin that we have here. It's going to be either heads or tails. So heads or tails, one side or the other. Nothing in between, no edges, nothing like that. And the same thing is going to be true with our hypothesis test. So our hypothesis test has to start out with an H naught that contains the possibility of equality. So that always has to be true of your H naught. Your HA is kind of like everything else. So let's see an example of that. And our first example here, example A, kind of matches a little bit of what you're going to see in the homework. You have these little drop-down menus, and it asks you to express the original claim. So the original claim in this one, there we go. Original claim. Well, that's going to go back to what we have up here. A majority of adults would would erase all their personal information on the internet if they could. So let's look at this claim here. Majority of adults would erase all their personal information on the net if they could. First of all, we have to decide what claim or what parameter we're testing here. Now, does the majority of adults, does that sound like an average? Does that sound like a mu? Not really. Thank you, Sam. Does it sound like a standard deviation? Does it sound like a population proportion? Yeah, that one's sounding a little bit better. It sounds more to the point. And let me help you translate this a little bit into a statement. This really translates to P, our population parameter, is greater than a half. Because once you're greater than 50%, not including 50%, but greater than 50%, now you're going to be in the majority. Now, if this is our original claim, we got to decide where we're going to put that claim. We've got two places, HO or HA. But there's something that we know about HO. What does HO have to contain? What does it have to have as part of it?
Equality.
Has to have the possibility of equality. Does this have the possibility of equality in it? No. So it can't go in the null hypothesis. It has to go in the alternative hypothesis. So it's going to be P is greater than 0.50. Okay. That's fine. Well, if this is one side of the coin, what's the other side? What's the opposite of being greater than 0.50?
P is less than or equal to 0.5.
Oh, well done. So let me look at it on a number line like this. So let's put in 0.5 here. P is greater than 0.5 is going to be everything to the right. So we'll look at it like this. Draw an arrow to the right. The opposite of that is going to be everything to the left. So let's draw another one of these. This time, instead of a hollow dot, because we're not going to include the 0.5, this time we're going to have a solid dot. We're going to include the 0.5. It's going to be everything to the left. And the way to describe this would be P is less than or equal to 0.5. So there you go. There's your null and alternative hypothesis for that statement. Yeah, so let's just circle that. That's what we're after right now, is setting up those null and alternative hypotheses. Good there, Cosmo? All right, thank you. Let's try another one like that. Let's come down here to this one right here. Claim that the mean pulse rate in beats per minute of healthy adult males is 68.8 BPM. Express this claim in symbolic form. Identify the null and alternative hypothesis. So let's highlight the actual claim itself here. So we want the mean beats per minute is 68.8. So the mean beats is 68.8. Let's start with part C here, and that is put that into symbolic form. What's that going to look like?
H0 is mu.
No, I don't want the H0 yet. Just this much. First of all, what parameter am I testing? Am I testing mu, sigma, or P? Mu. So it's going to be something about mu. Then what? What math symbol can I use? Joy? Suggestions? Is goes with which symbol, would you suspect? Some help? Equals. Is 68.8. Is goes with equals. All right. And then we could have greater than. At least would be this one. That would be at least. Oh, my bad. At least. At most. And is or equals. So different ways to say these things in words. But when you see these words, it goes with these symbols. Now, a question for you. Stephen, is this going to be part of the null or alternative hypothesis? Why the alternative? But that is equal, though. So what hypothesis do you want to put that in then? Actually, we're going to leave it as the same, but that's part of our null hypothesis because it contains the possibility of equality. If it contains one of these three, it should go in H naught. All right. Now, what's the opposite of being equal to 68.8? Not being equal. Thanks, Nicole. So not being equal is the alternative hypothesis. And again, it's kind of like flipping a coin. It's either heads or tails. It's one of those two. There's nothing in between. You have to decide one or another. So kind of like a jury trial. You can be found guilty or not found guilty. One of those two. I guess that's not a perfect analogy. I'm sure there's other things that can happen, but basically it's going to be a heads and tails kind of thing here for us. We're going to get some more practice with that. But one of the things that's going to help us decide, where we're going to go with this in terms of, do we believe the null hypothesis or do we think that the alternative hypothesis is true, is working with something called a p-value. So let's move on and work with p-values next. Now I should have a little sheet here for you, and you should have it in front of you, something like this. And you'll see that chart on a couple of these things, but here it is again. So your p-value is going to correspond to an area, and it's an area underneath a particular curve. That curve is going to be determined by whatever distribution you're using to perform a hypothesis test, but several things are in common. And that is, the form of this test is determined by the alternative hypothesis. So notice that all of these are HA. They're all alternative hypothesis. And that's what's going to tell you right tail test, left tail test, two tail test. Can you see the correspondence between a right tail test, a left tail test, and a two tail test? How do these things line up? What's going to tell you what to expect? Greater than is to the right. Mm-hmm. And then when there's two, it's not equals to tailed. Perfect. Now, that's true for the mean. It's also true for statements involving standard deviation and proportion. So it could be or if I had HA such that sigma is greater than some value, or HA such that P is greater than some value. All of these are going to end up in right tail test. Likewise, these are going to end up in left tail tests. Sigma is less than some value, or P is less than some value. And finally, the same thing is true of your two tail test. Sigma is not equal to some value, and sigma is less than some value. Oh, excuse me. P is not equal to some value. Yeah, pardon me. P is not equal to some value. So all these end up in two-tailed tests. What matters is the inequality symbol in your alternative hypothesis. That tells you what tailed test you're going to get. Now, our couple examples here might not have been enough for you to get really in the swing of null alternative hypothesis, but we're going to get to practice that a little bit more as we work with some of these other ones here. So let's move on to p-values. So our p-value is going to be the area in the appropriate curve for our test statistic based on the alternative hypothesis. That means we got to set up a null and alternative hypothesis first before we can actually make any headway on these types of problems. So let's take a look at the first one. Our original claim is this right here. So let's see what that's going to mean for us in terms of a null and alternative hypothesis first. And let me just zoom out a little bit. I'm going to put this down here. HO and HA. Okay, looking good there. Let's get that back on the screen. Where do you think this is going to go? Is that part of my null alternative hypothesis? This is my original claim. I got to figure out where that's going to go, HO or HA. Ian, by the window, what's your guess? You get a 50-50 chance if you're not sure, so take your best shot. Is this going to be part of the null or alternative hypothesis? Yeah, well done. HA. Why HA? Yeah, it doesn't have the possibility of equality. So if it doesn't have the possibility of equality, that's it. That's the alternative hypothesis. P is not equal to 0.28. Savannah, what would be the opposite of something not equal to 0.28? Okay, what would you state here in the null hypothesis for the everything else? What could I put in symbols? You can look back to our example D if it helps out. The previous one we just did.
So would it be P equals 0?
Yeah. P equals 0.28. So again, it's one or the other. You can't be both. There's no overlap in these two. So let's think. Is this going to be a right tail test, a left tail test, or a two tail test? What are you thinking? Hattie? Two tail, yeah. So what we need to do is we need to find the area under this curve. Now somebody make me look good. What distribution does a Z have? We're told that this is a Z statistic, a Z test statistic. How is Z distributed? Anyone? Normally with a mean of 0 and 1. Mean of 0 and a standard deviation of 1. Now, earlier in the semester, we used a lot of Google Sheets, and we found all our normal probabilities with Google Sheets. StatDisk can do that as well. The problem with StatDisk, and the reason I didn't use it as much, is because StatDisk only works with this one distribution. It can't work with a normal distribution with a mean of 100 and a standard deviation of 15, at least not directly. So, all right, let's go back to StatDisk, though, because StatDisk is pretty good for something like this. Not much of a surprise. You want to go to the analysis menu, then probability distributions, and then normal distribution to get where we need to be. So one more time, it's analysis, probability distributions, and normal distributions. Now looking at what we've got a Z value. We need to find an area. If you're using Google Sheets, you would use norm distribution, but we're not using Google Sheets, we're using StatDisk. So I'm just going to type in that value, negative 1.18, and it gives me a lot of information. What out of all this information do I want or need? So what's on the left would be 0.119. The area to the left is 0.119. Is that my p-value? Alex?
Sorry, well, it's half of yours.
Ah, it's half of your p-value. You want both of these areas. Now, there's a couple things you can do. You know that the normal curve is symmetric, so you could just double that. But we don't even have to think that hard, because they actually give you the doubled value, right? They tell you the two-tailed value, it's right there. It's 0.238. So total of 0.238, and that's going to be our p-value there. So a couple ways you can get that. It's whatever you're comfortable with. I think the two-tail there works pretty nicely. So let's take note of that. Our p-value is 0.238. Yay, because we had a two-tailed distribution. Are we okay with this first one here? Working with our p-values. P-value is something I expect and want you to be able to find. You're going to get problems like it in your homework. You should expect a problem like that on your exam. We're going to do 3 more like this to continue practicing. So our next one, let's look over here. Our original claim in this one is that P is greater than 0.28. Okay. So just like our last one, we want to set up a null and alternative hypothesis, HO and HA. Try and figure out, and I'll give you a minute, especially if you're watching this sometime later, to try and figure out, well, what's HO and what's HA? What's that going to be for us in this particular example? I thought you said it only does it in this class.
No, no, I mean, it bothers me more in this class because when I'm working with T or something, it's less aggressive.
Oh, okay.
But any other time, it's like that.
So that's when you have the static presentations that.
Yeah, yeah. I tried to get it fixed, but they said it was gonna take 2 weeks, so.
Remember up here, HO contains the possibility of equality. Does that contain the possibility of equality? Oh wait, you got a, is that equal to?
Yeah.
Equal to and less than equal to could overlap. Your null and alternative hypothesis can't have any overlap. So it has to be one or the other. Well, let's start out, is that going to be part of your null alternative hypothesis? You can put that directly into 1.
Put that in the issue.
Yeah.
Oh, I did that wrong. I just flipped the sign, that is the equal sign. Because all HA is, or all HO is.
HO has to contain the possibility of equality.
HA is A. If you have one, you just completely flip it.
HO has to contain the possibility of equality. There's no equal to.
I'm sure that'll change in like 2 weeks, but.
Like 2 weeks.
That is going to be right tail, correct.
And then the next step is to figure out,
I get it.
You got to start with HO and HA first.
okay.
So the way to start these out is with HO and HA. Does this contain the possibility of equality?
No.
No.
If it doesn't contain the possibility of equality, it can't be in HO. So it has to be in HA. So this one has to go here. It's going to be part of HA. P is greater than 0.28. All right, wonderful. So if that's here, what am I going to put here?
P is less than or equal to 0.28.
Yep, P is less than or equal to 0.28. Notice that again, your heads or tails, you're one or the other. This contains the possibility of equality. This is opposite this. Now just kind of a heads up for you on your homework, the book and the author are a little bit different than this. They're just going to put P equals 0.28. And then this one they're still going to leave is P is greater than 0.28. That makes it a right-tailed test. But they don't do this. I let you get away with this because I think it's a little more user-friendly. I think it's a little easier to think of it, you know, in your heads and tails kind of fashion that way. Now, we don't need this point at all, so I'm just going to get rid of that. Hasta la vista, baby. What tail test is this? Right tail, left tail, or two tail? It's a right tail test. So that means I want to shade the area to the right. What can you tell me about this area without looking it up? Yes, it's more than 1/2. So since it's more than 1/2, expect a number that's more than 1/2. If you don't get one, then look back at things. Now the good news is we don't have to type in anything new. We've already got this. In fact, can anyone see the area that we need?
0.881.
Yeah, the area in the right there. So it's giving you everything you could possibly want. It's kind of a catch-all there. But our p-value in this case is 0.881. So large as p-values go, but that's okay. That's what we're looking at for. So our p-value is 0.881. Great. Let's flip it over to the back. Are we okay with these first two examples here? Yes, please.
How did we know to use this first point versus the second point?
To use which one?
The first point, because there's two, I guess,
Oh,
Z-scores.
No, there's really one z-score, and it was z equals negative 1.18. And because it was a right tail test, we wanted the area to the right of there. I just put both of them here for your convenience on the first one, and then I copied this when I made the handout. I just copied it here because I knew I'd use it for the second one.
Oh, okay, thank you.
Yeah, no worries. I appreciate the clarification. Let's move on down to the next one here. And again, we're going to start out by stating the null and alternative hypothesis. So let's put this one, I'm going to continue to kind of keep them color coded here. Try and decide what hypothesis that's going to land in. Is it going to land in HO or HA? Which way we're going to shade, what tail test we're going to use. So I'll give you a little bit more time to work on this one. Thank you.
These need to be memorized, right?
Yes. But I hope that they make sense though. Points to the right, it's to the right. Points to the left, it's to the left. Not equals, two tail.
Okay.
So it should be,
Easy, okay.
yeah,
I got
it should
you.
be that.
Is this gonna be like explain
Well, let's form the alternative hypothesis. Those can both be true at the same time. If you use 0.5 here, 0.5 here, they could both be true. Your null hypothesis can never both be true at the same time. Null and alternative hypothesis could never be true at the same time. You look at the form of the alternative hypothesis, and ours was this. Which of these three is a binomial? There's your vector, there's your HO. Who is less than 0.2? Which one of these three is a binomial? Yeah.
That's it.
That breaks it all. You want me to make more complicated?
No, please don't.
You sure?
No, I'm
I can do
fine.
that. I'm really good at this minus this, this should be part of the alternative hypothesis because it doesn't include the possibility of quality. So make that HA, and then this would be HA.
Switch them around. Okay, thank you.
Good. Now find that value. How do you know it's a left tail? Less than. All right, so that makes a left tail test. So you want the area of the left tail to the left of that. It's probably not a bad idea to shade these things for yourself so you know what value, reasonable value to expect. So if we shade this, it's going to help us, kind of look at our answers a little bit objectively. So let's take a look at P is greater than 0.2. Where is that going to go? Is that going to be part of the null or alternative hypothesis? That's going to be part of our null hypothesis because it contains the possibility of equality. So if that's part of our null, what's the alternative hypothesis going to contain? P is less than 0.2. And if P is less than 0.2, what kind of a tail test is this? A left tail test. Good, so that's going to be a left tail test. So here's our here's our Z is 1.79. Let's draw on our left tail test. What's one thing you can tell me about the size of our p-value? It's going to be pretty big, right? It certainly has to be greater than 1/2. So we'll go to StatDisk again, and we'll look that up. This time we want to type in 1.79. And again, it's giving you a lot of different areas. But what's the one area that we want? 0.963. Good. So our p-value is the area in the left tail. That it's 0.963 shouldn't be terribly surprising because this looks like it's most of the area, right? So it's not a huge surprise that we got something like that. So our p-value is 0.963. Nice. Now we're going to kind of stick with that a little bit. We got a different test, a different hypothesis test here. Let's take a look at this last one, and let's see. Haven't quite run out of different colors yet, so I'll put this one in blue. Let's do this one together. Where's that going to be? Is that going to be part of the null hypothesis or the alternative hypothesis?
No.
The null hypothesis. It contains the possibility of equality. So that's going to be mu is less than or equal to 121. That's HA or HO. What's the alternative hypothesis going to have? Mu is greater than 121. Awesome. Ashley, let's see. Is this going to be a left tail test, a right tail test, or a two tail test?
Would it be right?
Well done. Yes, it is a right tail. All right. One of your classmates up front is also echoing that sentiment. So we expect something bigger than 1/2 or smaller than 1/2 here? Smaller, much smaller. In fact, it's going to be just kind of the opposite of this, right? So instead of 0.963, it's going to be 1 minus that. That's going to be 0.037 for our p-value here. And you can look that up just by looking back at our results from our previous one. It's going to be the area in the right tail, and there's your 0.037, or yeah, rounded off, it's 0.037. So that's our p-value on that one.
I have
Nice.
a question.
Yes.
So, is there a reason why you're highlighting one over the other?
I think I missed that, but,
What do you mean?
yeah. Yeah, you're fine, yes.
Oh, these, yeah. This statement ended up here. So I'm just showing you where that statement went. It had a quality in it, so it went into the null hypothesis. Same thing with this one. That one had a quality, it went into the null hypothesis. And on the front side, this one didn't have a quality, it went into the alternative hypothesis. This one didn't have a quality, it went into the alternative hypothesis. So, good question. Yeah, I'm just letting you, kind of follow my logic a little bit more in a visual way by doing that. So I appreciate that. Thank you.
The tail test is always done by HA.
The what's that?
The tail test is done by HA.
Yeah, the what tail test you're working in is always done by HA. So HA, HA, HA. It's always the form of the alternative that sets up HA. So great question. How are we doing on this? All right. Nice. So I'm going to split this up into a couple parts. So we'll do a part 1 and a part 2.